Okay. So now let's start. First, basically, I'll start giving you introduction about combined max. Okay. So now when you look at combined max, now if you ask the old people, like for example, your parents, okay, your parents and all of them, they don't know something called combined max. Before they use the word double max. The reason for using double max is because combined max, your syllabus is a combination of two key parts in mathematics. Now, mathematics has a lot of major parts. For example, statistic. When you take statistics, it's a branch of mathematics. So, like that, there are two branches of max called pure max and applied. Okay, pure and applied max. Okay, so now your combined max syllabus consists of pure mathematics and applied mathematics and also statistics. But thing is now statistics and probability is like 2 units. So only for those 2 units they can't give you a paper. Only for 2 units they can't give you a paper. Hence, only for pure and applied they give a paper, and statistics is added to this applied paper. Okay, statistic is added to the applied paper. So now you have two papers in your A-level exam. You have two papers called paper 1 and paper 2. So paper 1 is fully pure max. Paper 2 is applied. So your total marks, okay, is 2000 marks. Total marks for pure it's 1000, applied 1000. Okay. So this is the basic, like I'll introduce more about the subject bit more, like first day, so we'll start a bit basically saying about A levels. Now it's A levels is like, it's not like O levels. O levels you can, you can study even within like 2 months and get 9 A's, but A levels is not like that. Okay, A level you have to study from the beginning. Okay, because for example, you have 45 units in max. 45 units in max means it's a very huge content. Compared to chemistry, physics, combined max is the subject with the highest number of lessons. It's really hard to complete the syllabus. 45 units, 45 units have tutorials. You have to do the past papers. So you have to start studying from the beginning, actually. From the beginning, in a sense, from today. Whatever I'm going to do now, I'll be doing three sections today. So all the three sections, you should be able to study then and there itself. If I teach you today, you should revise it tomorrow. For the next class, like before the class starts, next class, I'll be giving you a morning exam, like 10, 20 minutes morning exam. So you should be ready, be ready to do that. By revising everything you have learned the last class, you have to start doing from next week. I'll be giving you the morning exam. So then you have to do that exam, like take 10 minutes. I'll give you the time also. So taking 10 or 15 minutes, you should do the morning exam. After that, I'll be checking it. You have to send me through WhatsApp. So after that, I'll be checking it and I'll give you all a reply. So you have to, you have to really focus on A levels, because there was a friend of mine. Okay, there are foolish people who do things. Okay, he got 9 A's in 1 month. He studied 1 month O levels and he got 9 A's. So what he did was, until the last month, A levels he did max. Until the last month, he didn't study. Last month he studied and somehow he passed. He got 3 S passes, and now he's struggling. He's like he didn't take a risk like that. From day one, you have to start studying. So that's how it should be. Okay, so A levels is not a joke. So you have to do everything on time perfectly. Okay, you have to start from today. Everything, you should do everything on time. Okay, so another important thing about A levels is just having knowledge is not important. Just having knowledge is not never like, even if you even if you study quantum physics, it's not important. Okay, you should be thorough with doing papers, because in the exam, everything you have learned, they give you a 3 hour paper. Okay, duration for one paper is 3 hours, 3 hours and 10 minutes, 10 minutes for reading. So in that 3 hours, you have to convey everything to the paper. So it's really hard. You have to have proper paper practice. You have to have proper paper management actually. So you have to manage your time, you have to manage the questions. You should know how many marks, if I do this question, how many marks will I get? So according to that, you have to make a plan according to the paper. We'll do in the paper class that actually. So in the paper class, we'll be planning how to do the paper. So planning the paper is very important. Like I'm teaching you theory here. Nothing is like, even if you just go do theory, you can get a B or A, like border A. You can't get a high A. Okay, so I don't want a small A, that means like 75 A. I want you to get 90, 95 plus A in the A-level exam paper. Okay, so getting 95, that 95 plus means it's a very good island rank. You should surely get around top 20 or top 10. So that should be the target. Okay, understood? Any doubts? Anything you want to know? I just want you to be really interactive. Huh? No, it's a little boring. I'm just teaching to a camera here. Any doubts? Everything is clear about the subject now. I'll be explaining more about the subject. Like when we go later on, when after some sessions, I'll be explaining more about the subject. You will, how you will understand. For the time being, is it okay? Can I get a quick confirmation? Okay. So shall we start work? Okay, small connection problem. Huh? You can hear me now, right? Clear and loud. Can I get a quick confirmation? Okay. Okay, so now let's start. Okay, algebraic application is the first unit. Okay, algebraic applications. So in this unit, now you don't get an A-level question from this unit. Now, thing is in A-levels, just because we teach, we don't get questions. That's the main thing. Huh? Now this is now thing is if you take O-levels is somewhere like here. A-levels is here. So there's a gap, no? To bridge this gap only we teach certain units. Like these are like steps. Without doing these units, it's a bit hard to go for future lessons. For example, this unit, when we do, you will understand that it is required for other units. For example, some big units, these are the basics. So without knowing these things, it's hard to bridge this gap. So if you want to reach this level, this is the A level, like top level. So for that, you should first reach here. No, this is the A level, normal level. Even if you fail, you have to reach this level only. Even if you are failing, you should reach this level. So then this is the bridge. These lessons are the bridge. So now this unit, there are 14 sections. Okay, there are 14 sections. We'll start section 1, expansion. Okay, now I want you to be really interactive with me. Okay, now I'm going to ask you some questions and I want you to answer. Okay, okay, what is the expansion of a plus b to the power 2? This you learned in O levels. Can you type it out? Because I want you to be really interactive. Huh? Can you type in the chat box? If not on the mic, and you can speak even if you want. Okay. So in O levels, you learned the expansion of this is yes, a squared plus 2ab plus b squared. And you learned something like this also, a plus b to the power cube 3. This with hard typing, you can on the mic and you can say expansion of a plus b whole to the square is a squared plus 2ab plus b squared. Then the power 3, you learn this in O levels. Okay, it's a cube plus 3a squared b 3a b squared plus b cube. Okay, so this is what you learned in O levels. Okay, so now if I say you to find the expansion a plus b to the power 4, now these things you memorized in O levels. These two expressions you memorized in O levels. But here in A levels, we have to the power 4, to the power 5, then 6, 7. So then how are you going to find? There should be a mechanism, right? Okay. So now we are going to find the mechanism which we are going any expansion, any to the power, any, even 100. You can use this method and find the expansion. So first there are some rules. Okay. So there are some rules. For any expansion, the number of terms is equals to n plus 1. If the power is n, the number of terms is n plus 1. I give a small example, a plus b, same thing. Okay, can you say me how many terms are there in this expansion? How many terms are there? How many terms can you see? This is one term, this is another term, this is another term. So how many terms are there? 3. So now what? The first statement says the number of terms is n plus 1. So here n is 2. That means here the power is 2, no? So how many terms are there? 3 terms. So it seems like what they are found, or these are things that which are found. So it seems like this statement is true. So if I take a plus b to the power 3, we have c squared b 3ab squared plus b to the power 3. So how many terms are in this 4? So seems like what they have told is correct. That means the number of terms is n plus 1, because here it's 3. So that means if 3 plus 1 is 4. Now I ask you another question. Okay. So how many terms does this have? I have written the expansion, but from this statement you can figure out how many terms are there in this 101. Simple, right? That's the first statement they have found out. So if there is 100, if n is equal to 100, the number of terms is 101. If n is equal to 50, the number of terms is 51. If it's 20, 21. That's the first statement. Okay. Second statement they told was, in any expansion, we have to consider one term, a or b, and we have to say a is descending. Okay, a is descending. Just consider a is descending. I'll explain why it's descending and everything. I'll explain. Consider a is descending, and what they told is, if we start with the highest power of a, then the power of a keeps on decreasing. What does that mean? If we start from a with the highest power, the power of a keeps decreasing. Same example. So in the first term, what is the power of a? In the first term, what is the power of a? 2. What is the power of b? Does b have a power? Actually, b, now in all of us, you learn something like this, right? Anything to the power 0 is what? Anything to the power 0. Anything to the power 0 is 1. So here, We have b to the power 0, but we can't see. Why? Why can't we see b to the power 0? Because it's 1. We can't see b to the power 0 because it's 1. So here that means we have b to the power 0 here. But thing is it's 1. Is equals to 1, so we're not writing. So what this statement says is, in each term, the power of a keeps on decreasing. See, here a to the power 2. Here, what's the power of a? What's the power of a? 1. Here, what is the power of a? The last term. Yeah, there's no a, but I told you, right? B to the power 0. Then here also you have a to the power 0. Then power of a is 0. Okay. So what they found out is, in each, if we can start from anything, we can start from a or we can start from b. Whatever we start, the power of a keeps on reducing. If we start from b, then we write b to the power 2. Then 2ab plus a squared. What happens to b's power? B's power keeps on reducing. Here it's b to the power 2, here b to the power 1, here b to the power 0. So that's what they told. If we consider, we can consider everything we want, a or b. But here I considered a here. So then a's power keeps on reducing. And on the other hand, what happens is b's power keeps on increasing. See, here b to the power 0, here b to the power 1, here b to the power 2. So what they found out was, this is a rule in when we start from a or b, a's power keeps on reducing, b's power keeps on increasing in each and every term. Now I'll get you into another example. This one I want you to say me. Let's go a to the power b to the power 4. I'm going to start by a to the power 4 and b to the power 0. What is the next term? Next term after this. If it's hard to type, you can mute, unmute, and you can speak. Okay. One term's power is decreasing, the other term's power should increase. So the next term, a to the power 3 d. Okay, first, how many terms are there in this expansion? How many terms should be there? 5. Yes. So then what's the next term? Term after a cube b. The next term is, yes, a squared b squared. Next term. Now 3 terms are done. Fourth term. Yes. A b cube. Next term. Last term. No, not last term. Yeah, last term. You can put 0 if something, you can put 0. Yes, b to the power 4. Now we don't write, we can write a to the power 0 also, but we don't usually write because a to the power 0 is 1. So this is b to the power 4. So see, but thing was now when you take a plus b squared, we had something like this, right? We have a number here, but here we don't have any numbers. That means this is not complete answer. This is a part answer. Now, if you ask me, is this a complete answer for this? No, it's not. Because there should be numbers. Before the terms, there should be numbers. So for that, we'll learn later how to do that. Now, these are the facts about when you have something like this, these are the facts. I'll erase, I'll give you the note. Okay. Now I just want you to say, like in a small piece of paper, write this expansion. That means no need numbers, only the expansion. You can start from A. That means you can highest power, you can start from A or you can start from B. Any power you start and you do and you send me through WhatsApp. Will you write this expansion? No need the numbers. I need only the expansion. You write the expansion and then send me through WhatsApp. I'll give you like 2 minutes. Yes. Any doubt? Asking this. First expansion in a sense. This one. Or the one I erased. You can unmute and speak. It will be better, no? Yeah. A to the power B plus 6. You have to give me the expansion. You can start from a to the power 6 or b to the power 6 and you have to write all 7 terms. There are 7 terms, no? Because n is equals to 6. That means there are 7 terms. So you should write all the terms but without the numbers. You have numbers in between, you have numbers. I don't need the numbers for now, but I need only this. Like you can start from A or B, anything, your wish. A small piece of paper. Don't write in the note. I will give you a proper note. So before that, just in a small piece of paper, write and send me. My WhatsApp number is 07752888833. 07752888833. It's a small error, okay? Small error. The fourth term, okay? Now, we have written a layered power for b cube, okay? Wait. Ah, sorry. Something is wrong. You start with, okay, you have started with b. Starting is with error, okay? A power 6, b to the power 0. You forgot b to the power 0. Okay. Until what time can you do? We'll finish on like at 10. Okay. So this is error, okay? We have done a small error. First term is a to the power 6, b to the power 0. After that, you have to increase. After that, you have to increase. Can you do that small error and send me again? One term starts at the highest power, other term starts at 0. Actually, with practice, it will be okay. We'll do around 20 questions. You can soon correct and send me. Yes, now correct. So remember, always the first term will always, now for this is expansion. No? So always the first term will be having the highest power of this same power. N power only this also will have. But then last term will have, that also will have the same power, but term will be different. Here a to the power 6, here b to the power 6. Okay. So now before one you had b to the power 7, no? That means it's like it's wrong. You like when you see it, you should be able to understand it's wrong. It should be 6. So that's the way you can identify whether it's correct or wrong. Okay. So that is the second point. Now third point, what they told is, again I'm using the same example. They told in each, this is, you call this one term. In each and every term, the sum of powers is equals to n. This is n no here. So what is the sum of powers? Here you have a, you have b to the power 0 no. Sum of powers 2 plus 0, 2. Here a you have 1, b also 1, answer is 2. B 2, you have a to the power 0 no, 0, answer is 2. So what they found out was, in each and every term the sum of the powers is equals to n. Here n is 2, so always sum of the power is equals to 2. Okay, that is another thing they found out. Did you understand, or should I give you another example for sum of the power is equals to 2? Okay. And another key word, okay, now this word is used mostly in lot of lessons. Okay, now this number is there, right? This number here also you have number, that means 1. Here also you have 1. So this number we specifically call it as a coefficient. Okay, what coefficient? Coefficient. In the exam they will use the word coefficient lot of times. Okay, so the number before the term, the constant number before the term is called coefficient. You know, if I ask you coefficient of a squared, what is the number in front of a squared? What is the number? 1. Now I want you to answer, what is the coefficient of AB term? What is the coefficient of AB? 2. So the constant number before the term. Now what is the coefficient of B squared? Coefficient of B squared, 1. So whenever they use the word coefficient, okay, that means a constant number before the term. So now when we expanded, now I gave you an example also. Wait, that's all we'll be using this example. So when I gave you an example, 8 plus b to the power 6 also, we didn't write numbers. So now there is a method. There are 3 methods actually to find that number. To find the coefficient, there are 3 methods. Okay, so we'll be learning about the methods of finding the coefficient later. But now we'll write this as a note. If not, I can't expect you to remember all these points. No. So we write a note. Write lesson name algebraic applications unit 1. Okay, unit 1 algebraic applications. Below that, write 14 sections. There are 14 sections like this, small sections. There are 14. Once you're done, algebraic applications, 14 sections. In that section 1 is expansion. Algebraic applications, 14 sections. Section 1 is expansion. Once you are done writing all the headings, say, I'll dictate you the note. Okay. So then write in the expansion. After writing section 1 in the expansion, a plus b to the power n. A plus b to the power n. After that, write semicolon. Write a semicolon. And write first point down. Write first point. Expansion has n plus 1 terms. 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 Second point, the power of a, second point, the power of a keeps on reducing. The power of a keeps on reducing. The power of a keeps on reducing, and in brackets write, consider a's power to be descending. In brackets write, consider a's power to be descending. Consider a's power to be descending, and then close the bracket, and then after writing the bracket, again write 2 semicolons. After that, write 2 semicolons and write this. Write semicolons, below that write this. That means what does this mean? This means power of n is decreasing. Power of a is decreasing. From a to the power n, an minus 1, an minus 2, an minus 3, dot dot. There are a lot of terms here. After that, a to the power cube, a to the power squared, a to the power 1, a to the power 0. Second point, this is the last line. You are done. When you're done, say, if you want me to repeat anything, then we'll say. Now, third point, the power of b. The power of b keeps on increasing. The power of b keeps on increasing. The power of b keeps on increasing, and in brackets write, consider b's power to be ascending. Consider b's power to be ascending. Consider b's power to be ascending. Close the bracket. Then write a semicolon. Below that write b to the power 0, b to the power 1, b to the power 2, b to the power 3, dot dot dot, b n minus 3, b n minus 2, b n minus 1, b to the power n. Once you are done writing this, take. That's the third point. Yes. Yeah, that's the thing. There are n plus 1 terms. Okay. But thing is, no, I can't be writing all the terms. No. That's the thing. I put 3 dots and I told this is a very big thing, but I've shortened it using these 3 dots. Even the before one, I shortened it with the 3 dots. This is like generally. Like this is not the real now. They don't give you n no in the exam, they won't give you n. This is not exam question also. Okay, this is expansion is related to a lesson called binomial theorem. So binomial theorem, they will teach you in the last term. We will teach you in the last term of your grade 13 last term only. Will be teaching binomial expansion. So in that they will give you a to the power. They won't give you n. They will give you 6 or 7, 8. Maximum they can give you is 8. Above that they won't give. So then according to that you can find the terms. But here I don't know the terms. Now n plus 1 qm, I don't know the terms. No, it could n could be anything. N could be 1 also. If n is 1, it's just 2 terms. So I'm just generalizing you saying 3 dots means that there are a lot of terms, but I don't know the terms. Yes, after the dots, bn minus 3, bn minus 2, bn minus power of b keeps on decreasing. For example, n minus 3 is there. If I want to decrease it, sorry, increasing power, b power is increasing. So bn minus 3, if I want to increase by 1 unit, what should I do? I should increase by 1. Then I get n minus 2. That means next term is n minus 2. Got it? Okay, then n minus 2. If I add 1, it's n minus 1. N minus 1 plus 1, answer is n. Power keeps on increasing. By one unit, power keeps on increasing. Okay, got it? Right? Just as a note, it's like confusing, but theory is okay. Theory, you got the theory, no? Okay, so the next point, fourth point, sum of the powers of each term, sum of the powers of the each term, sum of the powers of each term is equal to n. Sum of the power of each term is equal to n. Next point, next point, the constant number in front of each term, the constant number in front of each term, the constant number in front of each term is called the coefficient of that term. The constant number in front of each term is called the coefficient of that term. Done? Okay. So now generally after that, write this a plus b to the power n. Write what I'm writing. Write like this. Write down. Don't like write on the same line. Huh? I didn't have space, so I wrote down. So you, after writing this, write this, and then there are 3, 4 dots here. That means that this is a very big thing, but I've just reduced it to these terms. I'll explain what C note, C1, C2 is. Just write this, will you? Now this is a very complicated thing, okay? Thing is, it's like a complicated thing. But thing is, you already learned the theory. Theory is very easy. So I don't want you to defer this, but just when you see this in the future, you'll be able to recognize when you, because you'll be learning more bigger things. So when you learn bigger things, you'll be able to understand this very easily. Once you're done, say, huh? Any doubts, ask. Any doubt, you can ask. Okay, any doubt you get, any lesson, you can just ask me. Huh? Okay, down below that, right? Here C note, below that, right? Here C note, comma C1, here C note, comma C1, comma C2, C note, comma C1, comma C2, comma Cn minus 2, comma Cn minus 2, comma Cn minus 1, C note, C1, comma C2, Cn minus 2, Cn minus 1, and then Cn represent the coefficient of that term. Represent the coefficient of that term. Now I told you, before each and every term there's a constant number. And that constant number only because thing is, if I write like this and only write these letters, it's not a correct answer. But now you have C note, C1. That means a constant number, some number. Okay. So these are the numbers. These are the coefficients. C note could be 1. C1 could be anything. C2 can be anything. Okay, understood. After, if you have written the last point, just say done. Okay. Okay, now actually we are going to find this. Now, answer is not complete, no. Now, answer, when they ask you to expand AB to the power 4, if you do not know this C note, C1, C2, answer is not complete. Your answer is wrong. So now we are going to find the methods, we are going to find the coefficient. That is called the coefficient. So now we are going to find the methods, we are going to find that coefficient. Now write the next topic, finding coefficients. Finding coefficients. If you write methods to find coefficient. Right? Methods to find the coefficient. Subtopic. Below that, right? Below that as a point, right? There are two methods. There are two methods in GCE A level. There are two methods in GCE A levels to find the coefficient of each term. In A level, there are two methods to find the coefficient of each term. Below that, after writing that, put after semicolon, write 1 Pascal's triangle. First method is Pascal's triangle. Second one is combinations method. Pascal's triangle, first one. Second one is combinations. Done? Okay. So in front of combinations, in brackets, write taught later. Taught later. Write taught later. Because that's a bit hard to understand. In the first day, teaching combinations is hard because it's a very big concept. Combination and permutation. If you, I have 45 units. I have sent the 45 units. If you haven't received it, send me a WhatsApp message. You haven't received the 45 units. So in that 45 units, combination scale, there's a unit actually. So it's a very, it's a not complete, it's a practical unit. So on the first day, I can't be teaching you combinations. It's a bit hard for you to understand. I can teach, it'll be hard for you to understand. Okay, but I'll just give you a small basic idea about combinations later after finishing Pascal triangle. Okay, so write taught later. After that, write subtopic Pascal triangle. Now there's another method to find the coefficient called the Newton's method. So Newton's method is too complicated. It's not there in the syllabus. Pascal triangle is easy. You can find the coefficient using the Pascal triangle. Now, if you ask me, is this an A-level question? No, this is not an A-level question. This is too easy. Okay, this is not an A-level question, but there's a similar question you will get. We'll do one A-level type question. I have one in the tutor. The tutor most probably will get taking it next week. Okay, so in the tutor, okay, Pascal triangle, in the tutor using this expansion, you can do one question. In the pure paper, you can do question number 3, question number 4, not 3, 4. So that is also, but this is a very lengthy method. So you have an easy method in binomial theorem. There's an easy method in doing this in the binomial theorem, but here we are teaching the basics. Thing is, if you do not know the basics, because in O levels, you learned, you just memorize, no. Now you know how it comes. Now you know how this comes. Now, when I say a to the power b whole thing squared, now you know how it comes. But before A levels, that means in O levels, you'll just memorize, no. That's no point. They should have at least taught you all this. That's the thing. This is, I'm calling this, I'm bridging the gap between O levels and A levels. I'm bridging the gap. Thing is, y'all are like, you now, y'all are not taught much in O levels. Okay, so right. So did you write the topic Pascal's triangle? Subtopic? Okay. And a small point, okay, I forgot. First, you wrote something on this side. When we consider a plus b to the power n, first line, consider the expansion of a to the power b plus n. First line, I told you. Okay, beside that, write n is a positive number in brackets. After the semicolon, write n is a positive number. So only when n is a positive number, this is applicable. For example, if n is, imagine half minus half, you can do, but it's yes. Can you explain? Okay. What I told is, now in the first page, you wrote no. Consider the expansion of a to the power b to the power n. First page, first line actually. Okay. After the semicolon, right? N is a positive number. Right? N is a positive number. Now, why am I saying n is a positive number? If you take n is half, so then what is the next term? First term, okay, I'm writing a to the power half. Then are we going to decrease it by 1 unit? You can't do that. B to the power 0, you don't even know how many terms are there. If you take the terms, half plus 1, there is 3.2 terms. That's like impossible. How can you have 3.2 terms? 3 over 2, that means 1.5 terms. Half a term is missing, that means. It's like, it's wrong. So n should be a positive number. 1, 2, 3, 4, 5, 6 until infinity. Okay. So that's a small point I missed. Now share. N can be negative also. And it's negative. Let's do something. You won't get negative numbers. You will get only positive numbers in your exam. Okay, write theorem 1. Theorem 1. And I'll send you a small pic. I want you to copy that in your book. Did you receive 2 pictures? Yes, copy that in the book. Right? Theorem 1, Pascal's triangle. Below that, copy that to you. After that, I'll explain. So before that, okay, I want to say, ask you, like, say, now, max now, expansion. I started from the basic O-level thing and I went from the basic O-level a plus b to the power squared, I went to a big theory. So there are certain units, for example, like the Pascal's triangle, where first you have to do and write, after that only you will understand. First you have to write the note. For example, there is a lesson called induction. Okay, so induction, if I explain, you won't understand. So in A-levels, it's like that only. If I explain you sometime, mostly you won't understand. The reason for that is, without doing questions, it's really hard for you to understand. So there are units where I will say you to write the theory. I will say, write this, then you have to write. After that, I will give you a question to do. You have to do. By reading the theory, you have to do. Like 80%, you won't be able to do it. But that's a task I'm giving you. Read the theory and then do the question. After that, what I'll do is I will explain the question and then you have to do the question alone again if you can't do it. I'll explain the question again, you have to do it. After that, what you have to do is you have to read the theory then. Then also you will like have problems in the theory. Then again, I'll give you another question. This one you have to try alone. Then also sometimes like 50% you'll be able to do it. After that, I will explain the question again. After that, again you will read the theory. And then only you will understand theory. So certain lessons in max is like that only. It's not like this is very practical. Like this is not practical, no. Now, for example, I'm saying expansion. Why do you expand? Do you have any practical use? No, right? Just expanding an expansion, you don't have any practical use. But we are just doing, no, for God's sake, we don't know. Allah, Allah, why we are doing that? But we are doing it, no. So we don't have a practical use. So it's really hard to understand certain concepts. Now, for example, in O levels, you learned solving expressions, algebraic expressions, like you find value for x. Why do you do that? No, don't know, no. So like that in this also we have uses, but thing is it's beyond our like understanding. That happens in pure maths. Applied maths, everything is practical. It's like two sides of a coin. Applied maths, everything is practical. Like we speak about bullets, shooting someone, how to, in what angle should we shoot so a person that distance can be shot. Now all these snipers, all these murderers and stuff, they learn physics. Now this is physics and applied maths. Physics basics and applied maths basic, like physics very hard questions and applied mathematics easy questions are like same. Like applied maths basics are physics, like physics very hard questions are applied maths basics. So these people, they study physics to shoot and do all those to aim and everything. They study physics. Okay, even for rockets now, that war going on in Palestine and all, they use physics to target the place. Now, if a person is moving in the car, you have to calculate the speed, and according to that, you have to make the angle. All those will be learning in applied maths. But in pure maths, we don't have real meaning. Okay, we don't have a real meaning in pure maths. But what to do? We have to study now. In order to pass this, you have to study. Okay, now if you are done with, just do this thing. Pascal's triangle, the one I sent you. I will explain what that means. Once you are done, send me a message. Huh? Okay, done. So now this is the coefficient rule. Okay. Now in the photo I sent you, you might have already written. This is what I told you. To the power 0. Now anything to the power 0 is 1. No? So Pascal also found out anything to the power 0 is 1. Now Pascal is a very big mathematician. Now he found out anything to the power 0 is 1. Now okay, anything to the power 0, we are not considering it here. Okay, we are taking a to the power 1 here. We don't get this much, but okay. So what Pascal told is, now if you have a plus b to the power 2, you have 3 terms. So in the Pascal triangle also, you have 3 numbers like this. He told first term number is 1, second term number is 2, the coefficient, third term coefficient is 1. Now how did he find it? Now that's a big question. Now anything in max, okay, you should have proof. Just you can't get no. How did he get this? So what he told is, first don't check from the first term, check from the second term. What he did was, in the left hand corner and the right hand corner, it's always 1. In the middle only there should be numbers combinations, which he told, if you add the first and the second number of the before term, you get 3. 1 plus 2, 3. Then add this and this. That's what he told. Now there should be 4 terms. Now a to the power b cube, there should be 4 numbers. What he told is, always on the right hand side and the left hand side, number is 1. So in the middle there are 2 terms. What he told is, you add this and get this. So then add this and this, first and second term, then second and last term, and get this. Correct, no? What he told. Let's check here. Here same number, 1, 3, 4, 3, 3, 6, 3, 1, 4. 1 always 1 is there. This one he told, 1 plus 4, 5. 4 plus 6, 10. Then 6 plus 4, 10 again. Then 4 plus 1, 5. Wow, what a method, no? He found a very beautiful method. Now, other methods are hard. So, what you will do is this method in practice actually. Okay, with practice, you can find. Now, this is a very beautiful method. What he found out was a very beautiful method, Pascal. So, now I want you to write, give me the number combination. Give me the number combination. Now, on the left hand side, it's 1. On the right hand side also, it's 1. How many numbers should be there in between this and this one? How many numbers should be there? Now power is 6, so how many terms should be there? Yes, 7. Yeah, 7 terms are there, but I already gave you 1 and 1, so there are already 2 numbers out. So now how many numbers are remaining? 5. That means there are 5 numbers here. Now how do you get the combination? What I told, how do you get the combination? Add these 2 numbers to get the first combination. What is it? 6. Then to get this, add both of these. What is it? Answer 15. To get this, add these 2 numbers. 20. To get this, 15. This, 5. So now, for example, now if you want to get a to the power 6, you need to know to the power 5 expansion. But the thing is, now in the exam, this is not a tested question. Okay, you didn't understand. Okay, wait. Okay, so I told you always the left hand number and the right hand number is 1. In the Pascal triangle, the first number and the last number is 1. So in the middle, there are 5 numbers, right? There are 5 numbers. How do you get this first number? Addition of these two numbers. First two terms of the before expansion, not this expansion. Before expansion only gives you this number. So what is 1 plus 5? 1 plus 5, 6. This number is given by these two combinations. Now, like we move step by step. First two, after these two, after these two, after these two, after these two. What is the addition of 5 and 10? 10 and 5? 15. Give me this answer. We added these two, then these two, now 20. Now next, what is this number? 15. This number? Yes, 6. Now give for 7, will you? How many numbers should be there? How many numbers should be there for 7? 8. This number is fixed. We are not changing. We are not going to do anything. So then there should be how many numbers in middle? 8 numbers should be there in total. How many numbers should be there in the middle? Yes, 6. 6. So give me the number. What number should come here? We should use this. For this we use this. Then for this we should use this. 7. What number should come here? 21. This 35. This 35. Here 21. Here 7. Easy, no? But thing is, can you remember all of this in the exam? Now in the exam, I told you this is not a tested question. This is not a tested question. But when you are doing your first term test and stuff, you will be sometimes, most schools, they don't do this. But some schools, they do. Like, for example, if you take Royal College, the big schools, they do this. So then when you're doing those in term tests, these will be tested. So that how I'm going to memorize? I'm going to memorize this? No, that is by practice. When you do around 20 to 30 questions from this unit, you will automatically you will remember. If it's 5, the coefficients are 1, 5, 10, 10, 5, 1. If it's 6, 1, 6, 15, 20, 15, 6, 1. If it's 7, 1, 7, 21, 35, 35, 21, 7, 1, you will like automatically you will understand or you will remember. Now in your syllabus, we have been told to teach only about 8 until 8. Above 8, you won't get. Now this is actually a A-level question, okay? But thing is now we can't be doing in the exam paper because one question we get is around 4.5 minutes. To write this itself, it will take 4.5 minutes. Sometimes to write this for some people itself, adding each number, it will take 4.5 minutes. So that's a easy way to find the number, like coefficients. That is, you will be learning in the last term of grade 13 called binomial theorem. So for that, the basics is this. This is the basics for binomial theorem. Okay, understood? Okay. And as a new person, like, yes. Okay. If you can't, for if it's hard for you, you can leave. Okay. But now to the institute, you should send a feedback about the class. You should send a feedback and you should speak with sir. Now, sir's number is wait. Okay, this is sir's number. You would send a small feedback to him about the max class. Did you understand? And he will ask you more questions. Okay, should send a small feedback to him, inshallah. And sir asked me to ask you if you're continuing the max class. If you wish to continue, you can say. If not, if you want to explore other options, other classes, you can say me, and you can say, think and say. Do you want to continue for? Okay, you send sir a message. If you want to continue anything, send sir a message. Okay. So inshallah, Friday we'll keep the class. This Friday, that means in 3 days. Okay. Okay then. Friday, Friday is fine or Tuesday is fine. You say the time, will you? Because only you're there, no? Friday, Friday, Friday evening, 3 to 7 only, I thought. But now we can keep on Thursday evening. Like Thursday, we can do until your school start. We can do on no. From next week, I have lectures. So like Thursday evening or Friday evening, you send me a message. Thursday evening or Friday evening. Sorry, not Thursday, Tuesday. Sorry. Tuesday evening or Friday evening. Thursday I have a class. Tuesday evening can, right? So then inshallah next Tuesday we'll meet. Okay, next Tuesday. Okay. You can you just send a message to sir now itself. You can. He's expecting a message now itself. Okay. Okay then. Okay. Assalamu alaikum. Okay.